Rocket-powered sleds are used to test the human response to acceleration. If a rocket-powered sled is accelerated to a speed of 444 meters per second in 1.8 seconds, then what is the acceleration? And what is the distance in which the sled travels at that time? Now, if we pay attention, we have two questions here. One is, what is the acceleration? But then we have a totally different question that says, what is the distance? Now, this is pretty common amongst FNEOM problems because as soon as you've established your givens, there's two different equations. Well, let's take a look. We know that our rocket-powered sled eventually makes it to a velocity of 444 meters per second. And we are told that it only takes 1.8 seconds to get from one place to the next. We need to infer what the velocity is in the beginning, and that is 0 meters per second. We can figure that this is an initial velocity, and this is a final velocity. Since I'm working in the x-axis, I'll put it in red. My initial velocity equals 0 meters per second. My final velocity is going to be 444 meters per second. And because time does not have a direction, I'm going to write that in black, 1.8 seconds. Now, there are two problems here. If I am looking for the unknown of acceleration in the x-axis, I can go this route, and that's going to be in meters per second squared. But if the unknown that I'm looking for is distance in the x-axis, I'll go this route. Okay, the equation that I'm going to use in order to solve for acceleration is going to be velocity final equals velocity initial plus acceleration times time. But the equation for this one, if I wanted to figure out distance, is distance equals 1/2 velocity final plus velocity initial times time. If I substitute numbers for letters, my velocity final here is 444 equals, my velocity initial is 0, times the acceleration, which I don't know, times time, which is 1.8 seconds. If I clean this up a little bit, because the 0 can drop away, I get 1.8 times acceleration. In order to get acceleration all by itself on the right-hand side, I'm going to divide by 1.8. That allows me to cancel. Whatever I do to the right, I have to do to the left, and I get acceleration equals 11.17408 meters per second squared. And if I find the significant figures, the time here has two significant figures, and so therefore I'm going to respond with two significant figures. My acceleration is 246.66666, also known as 6 repeating, meters per second squared. If I take a look, I see that my time has two significant figures, so therefore my answer is going to have two significant figures, and I'm going to respond 250 meters per second squared. Alright, back to my second one. If I replace numbers for letters, I don't know what distance is, but 1/2. Let me write it this way, over 2. My velocity final is 444 plus 0, that quantity, times the time of 1.8. So it becomes simpler, 444 times 1.8 divided by 2. Distance equals 799.2 divided by 2, and I get a distance that equals 399.6 meters. And so when you apply significant figures, you only need 2 significant figures. So the number rounds up to 400, but we need some way of indicating that there are only 2 significant figures. Now you can do this with 2SF along the arrow, or you can put an underline underneath the first 0.